Because how many ways are there to solve math?
Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is?
2 times length plus 2 times width.
And good afternoon. Welcome to the elementary edition of Count on Us. I'm Miss Shirey, and I'm here today to help you with your math homework. My math partner will be here soon. He's just working out a few little math problems for us, so as soon as he gets in, he will join us with the show. And right now, we want to just get started right away with the challenges for today. We have some Challenge 24 problems for you to work on while you're watching us and while you're waiting to call in. Here's some of our challenges for today. We have Challenge 24, 4 different problems. Remember, you're taking all 4 numbers. You're trying to add, subtract, multiply, and divide them to make the number 24. So card A, we have 2, 3, 4, 4. So you have to use the 4 2 times. Card B, 23, 12, 22, and 9. That's 9 with the red circle there. This is a double-digit card, so it's a little bit harder. Card C is 4, 2, 5, 1. And card D, 8, 6, 2, 4. But I know that you will get them right because you've been working on them and you've been playing first in math. Here's our other challenge of the day. It's our word scramble. All right. I have some scrambled letters down here for you. And what you have to do is call in and ask me some yes or no questions about math, and then you'll try to guess my secret word. All right? There's the number flashing at the bottom, 301-772-0080. So make sure you call in and ask me about your homework. All right? Well, in the meantime, we're going to go over a few skills that I know that you are struggling with. Some of the hardest skills that we've been working on this week have to do with time and elapsed time. And it's really important that you have a clock at home, and hopefully your teacher has taught you how to make a clock on like a paper plate or just on a piece of paper to help you so you remember how to count the time. All right? So a few tricks I want to show you today. Let's go to the work mat. The way I've taught my students to make a clock, they can just draw one at home. All right, first thing we're going to do is we're going to put 4 little benchmark numbers in here when I make a clock. All right, I put my 12 at the top, of course, 3, 6, and 9. And then if you do that, it makes it real easy to space out all the other digits for your clock. Now I'm writing a little bit sideways here, so it's not quite as spaced out as I would like it to be. Okay? Well, there you go. Now, one of the things that my students have been struggling on is time to the half hour. So, for example, the hour hand, of course, that's the shorthand. And I always tell my students that the hour hand is the shorthand because if you spell out the word hour, it's H-O-U-R. And that's a shorter amount of time than the minute hand. And the word minute is longer than the word hour. So the minute hand is longer than the hour hand. Okay? All right. Now, this is how you can make your clock. And when we come back, I know we have somebody on the line, so I want to get to that person right away. So while you're waiting, if you want to work on some time with me, you can draw your own little clock face. And we'll get right back to that in a minute. But we have a caller. Welcome to Count on Us. Hello, who's out there?
Hi.
Hi, who is this?
Tamawa.
Hi, Tamawa. How are you?
Good.
Good. What school are you calling from?
Dodge Park.
Dodge Park. Great. And what grade are you in?
4th grade.
4th grade. Okay. And what can I help you with today with your homework?
Division.
All right. What kind of division? What's the question for today?
83 divided by 4.
Oh, 83 divided by 4. Okay. All right. Oh, my marker is running out here. Let me get my red one back. So 83 divided by 4. Okay. Now, do you have a strategy that your teacher taught you? How did you start this problem?
Multiplication. You have to divide, then you multiply, then you bring down the number.
Okay, so let's start with the dividing. How many times can 4 go into 8? What's 8 divided by 4?
2.
Right. 8 tens divided by 4. It'll be 2 tens in each group. Now what do I do?
You multiply. You multiply.
Multiply, right? What two numbers do I multiply?
4 times 2
2 times 4 is what?
is
2 groups of 4. 2 times 4 is 8, right?
0.
No, 2 times 4 is 8. You're ahead of me. 2 times 4 is 8. Okay, now we can subtract. What's 8 minus 8?
0.
Right, 0. Bring down the...
0. 3.
Right, bring down the 3. Okay, now we do not have a number up here in our quotient. We still need a digit up here. How many times does 4 go into 3?
0.
Right, I can't make a group of 4 out of 3. Now what's 0 times 4?
0 times 4 equals 4.
That's right. 0 times 4 is what? Not 4.
Oh, 0.
Right. 0 times 4 is 0. Now subtract. 3 minus 0.
0. Oh, I keep making mistakes today. Sorry.
Yes. I think that's what's catching you up here. Remember, when you multiply by 0, the answer is 0. But when you subtract, what's the rule for subtracting with 0?
You have to bring there's no number. You have to bring it down.
Well, it's going to be the same number, right? So 3 take away 0, you're going to still have 3.
3.
Okay? So there's our answer, 20, and then we have leftovers. We have remainder. 20, remainder 3. All right, Tamawa?
All right.
Does that help you out today?
Yes.
Great. Okay, can you show me how to check this answer? Can you check so we can make it correct, so make sure that we did it correctly? What's the opposite of division, Tamawa?
Multiplication.
That's right. So if we multiply our quotient, our answer, times our divisor, 20 times 4. Okay, Tamawa, what's 4 times 0?
0.
Right. 4 times 2?
8.
Right. Okay, and then we still have a remainder. So what we do is we add those extra remainders on. Add that last part for me.
83.
Right. 0 plus 3 is 3, and 8 plus nothing is 8. 83, is that what we started with?
Yes.
That's what we started with, so you got that problem correct. Very good, Tamawa. I'm going to put your name in the apple. I'm going to shake it up. You're the only person in here so far, but I guess you have a good chance of winning. All right. Did you want to try one of our challenges today?
Yes.
Which one? Did you want to try a challenge 24?
Yes.
All right, let me put them up one more time for you so you can see them. Did you want A, B, C, or D?
I want it B.
B as in boy?
Yes.
Okay. So the numbers are 23, 22, 12, and 9. Whoa, those are some hard numbers, Tamawa. Go ahead.
23 take away 22 equals 2.
Are you sure?
No.
Why don't you work on this one a little bit, Tamawa? All right, I put your name in the apple, and why don't you copy these numbers down? 23, 22, 12, 9. Keep working on that and call us back, okay?
Okay.
All right, thank you, Tamawa. You have a good afternoon. All right, I think Tom was gone. Hello, Mr. Grubb.
Ah.
You are back.
Back for more. Back for more.
Back for more. You've been getting some problems together for us. Some great ideas to share with the kids on the show today.
Am I sharing today?
I was sharing. I already started my sharing time. I was sharing about telling time.
Oh, telling
My
time.
My sharing time was about telling time.
Okay, okay. Well, we're working on graphs, all kinds of graphs. I don't have any graphs.
I know. That's hard to share here. That's why I share time, because it's not as hard. But it's very important. You have to know how to tell time. So I drew my handy-dandy little clock.
Excellent.
Can I tell you about the hour and minute hand while we're waiting for a new caller?
Please.
The hour hand and the minute hand. See how the hour hand is small?
Yes.
And see how the word hour is small?
I see that.
That's how I know which one's which. And the word minute is longer.
Longer, so is the
That's how
minute
you know.
hand. Oh, I like that.
And it's kind of tricky. I was teaching my kids today that sometimes when you read a clock, you have to take your eyes and you have to kind of make this imaginary line that extends past, so that you can extend your hour hand and you can see which hour it is.
Right.
Because
if it's either past one or it's going towards one.
Right. So if it's in between, if it hasn't quite gotten to that next number, it's always the number before. So this would be 4 something. So I teach my kids, we always read the inside of the clock first and then the outside of the clock.
I think that's why students like digital clocks better.
I know, but really, this is like the greatest. Okay, then you can start counting the outside, which will have all those little tick marks. But I don't have time to count up all those tick marks because there's 60 of them, because there's 60 minutes in an hour.
Right.
So I just count by 5s with the big numbers.
That makes sense.
Yeah, so 5, I start here, 5, 10, 15, 20, 25, 30. My minute hand is stopping at the 6, so, it must be 30.
And that's also halfway. If the minute hand goes from 12 and it goes down to 6, it's gone halfway.
That's right. I teach my kids to draw the line, and the minute hand has gone. I actually have them shade it. It's gone halfway around.
I like that.
Yep, that's
Half
why we
the
also
pizza's
call
gone.
it half past 4. Yep.
Yeah.
So it has like a nickname. It has 2 names.
Cool.
So that's what we've been working on. But we're going to start elapsed time pretty soon, and that's really hard.
Elapsed time. I can do something with elapsed time.
You want to help me out with elapsed time?
Sure.
Well, I erased my clock, so I hope you have...
Erase your clock. Well, I do have a strategy for it.
Okay.
Elapsed time.
Help me with elapsed time.
Okay, so let's say that we
Yes.
get up at 7:25 in the morning.
Wow, that's late. I'm at school by then. Okay.
Depends on if you're an early school or a late school.
Yes.
I'm in early school. We're also at school at that time.
Okay, so 7:25. Yes, we're
Is
getting
your wake up. And you have to be at school at 8:45.
8:45. Oh.
So late school again.
Oh yeah, 8:45.
So then the
Okay.
question is, how much time has elapsed?
Oh, elapsed means like past. Like how much time has gone by?
Past.
Oh, I get it. I get it.
But I'm
Cool.
bummed.
But I'm
So,
bummed.
we have several strategies. I like to use geared clocks because then we can actually see the clock and move with the motion. But what I like to do is we can move in hours. I like to move hours first and then minutes.
Me too.
So if we have 7:25, 1 hour away from 7:25, some people like to do it in a linear fashion. Some people like to do it in a vertical fashion. So 7:25, an hour away from 7:25 is
8:25.
8:25, and that's 1 hour. Now, an hour away from 8:25 is 9:25, so that's too much.
That's out. That's too far. You would
Too
be late
far.
by then.
I'd be late for school. So we can go, since these are nice, easy numbers, I made it that way, 8:25 to 45, we have nice, easy numbers. We can count by 5s. So 25 to 8:30, that's 5 minutes.
5 minutes. Okay.
And if you're real good, you can go from 8:30 to 8:45, which is 15 minutes. But let's say you can't go that far. So 8:30 to 8:35, that's another 5 minutes.
Okay.
8:35 to 8:40, that's another 5 minutes. And 8:40 to 8:45, our final destination, that's another 5 minutes. So I have 1 hour here.
Okay. 1 hour.
And my minutes 5, 10, 15, 20.
1 hour and 20 minutes. That's a long time to get ready for school. I bet
That's
you
a
can
lot
make
of
it.
time. You can eat breakfast,
Yeah.
watch at least one cartoon.
I know, that's
Just don't get
great.
stuck watching those cartoons because you can stay there for a while.
I know. Well, we have some callers.
Ah.
We have someone else calling. Tamawa. Is the
Tamawa, you
Tamawa
back for more?
Hello?
Hello,
Hello, who is this?
Tamawa.
Tamawa, how are you?
Good.
I bet you're calling back for a challenge.
Yes.
Okay, and which challenge are you working on?
24.
The second one again?
Uh-huh.
Okay, 22, 23.
That card scares me.
I know, that's a pretty scary card. 22, 23, 9, and 12. All right, anytime you're ready.
12 plus 9 equals 21.
12 plus 9 equals 21.
Oh, I just got it.
Okay, keep going.
21 plus 23 equals 43.
21 plus 23, or 22. Which one were you adding?
21 plus 23.
21 plus 23 equals,
43.
are you sure? 43?
And then 44.
44, okay.
40. Could you write that, please?
Yes. All right. So you have 21.
42.
Okay, so you have 21 plus 22
Yeah.
equals what?
43.
43, okay.
43 minus 22. 23
Because you've already used the 22.
equals 24.
Oh, close. No, very close, Tamawa. Okay, it's not 24. You're a little off in the ones column. Okay, just call back, all right? We'd love to hear from you again, all right? Call us back. But we're going to go on to our next caller. Hello, welcome to Count on Us. Hello?
Are you there?
Hello?
Hello, who is this?
Jatasia.
Hi, Jatasia.
What school are you calling from?
Dodge Park.
I knew it. I knew it. What grade are you in?
5th grade.
All right. Do you know this guy right here?
Huh?
Do you know this guy?
Yes.
He's such a crazy teacher. Look at him. He's so much fun.
Sometimes.
Did he give you a lot of homework? Is he your teacher?
Yes.
Oh, okay. Well, tell us what he gave you for homework. What are you working on?
Well, today he didn't give us nothing for homework, but I'm studying. And then for what I'm studying, it's like for the gas gophers paper that we had just went over today.
Oh, so your homework was to study some of your previous work?
Yeah.
Okay.
And watch Count on Us.
Okay. Well, hey, that's important too. All right. I'm glad you're checking over your previous work because that's how you learn about your mistakes. It's okay to make a mistake, but you don't want to make it again. All right. So what question are you working on?
So it's like they have 5 different types of cars,
5 cars. Okay.
and it's a graph. It's supposed to be
It's
a
a
graph.
graph. Look at that. It's
a
your
double
graph.
bar graph. We did that
Double
last
bar
week.
graph. Okay.
And one is representing the highway driving,
Okay.
and one is and then the other is representing the city driving.
Okay.
And then when the flash, one of the cars is the flash car, and for the highway driving it's 20
Okay. So for the highway, it's 20.
miles per gallon, and for the city driving it's 18 miles per gallon.
Oh, that's not much of a difference. Okay.
And then the meteor is for the highway driving is 31.
Is this for another car?
Yes, for the meteor.
Oh, the Meteor car. Okay. So on the highway, that car gets 31 miles per gallon. Okay.
And then for the city, it gets 20 miles per gallon.
20 miles per gallon, okay?
And then the rate, we're going on to another car.
Okay.
The rate go is 36 for the highway.
Okay.
And the city is 25.
Okay.
And we have 2 more cars left.
Okay.
And we're moving on to the next car. For Vonda, it's 37.
37 highway?
Yes.
Okay.
And for the city is 24.
24 miles per gallon. Okay, and the last car?
The X57 is 21 for the highway.
Okay.
And 14 for the city.
Okay, all right. And do they have some questions for you with this data?
Huh?
Do they have some questions?
Yes.
Okay, go ahead with your first question.
How many more miles per gallon does a Raygo get on the highway than in the city?
Okay, which car was the Raygo again? I should have labeled each of them.
The one with the 36.
And the 25?
Yes.
Okay, so the question was, how much farther can it go on the highway than the city, miles per gallon?
Yes.
All right, aren't you comparing the highway miles to the city miles? You're kind of comparing them, aren't you?
Yes.
You're kind of saying, okay, this gets this and this gets this, so how much further does this get than this? What you're really doing there is comparing. Whenever you have a problem that says like, how much more, how much taller, how much bigger, how much further can the car go with that on that gas mileage, what you're really doing is comparing. Do you know what operation you use to figure out a comparing problem?
No.
Well, you use subtraction, because what's going to happen is, if on the bar graph, you told me you had a double bar graph?
Yes.
Okay. And I bet that the highway for 36 is going to be taller than the highway 36 is going to be taller than the city 25, right?
Yes.
So what you're looking for is this missing piece in here. What is the difference between this height and that height? You're comparing them and you want to know how much taller really that bar is on the graph. How many extra miles per gallon can you get if you're on the highway? That's what it's really asking you. So that's like the bigger part of this question, is understanding that when you're comparing, you are always going to subtract. Right. So let's subtract these two numbers. That's pretty easy. You know how to do that, right?
Yeah.
36 minus 25. Impress me.
6 minus 5 is 1.
Yep.
And 3 minus 2 is 1.
Very good, 110. So really, you're getting 11 miles to the gallon more if you drive it on the highway than the city. Okay?
Okay.
All right, any other questions for this one?
No.
That is wonderful. Well, I am not going to erase this because we might use this for another question. Since we have the data, we might as well keep it.
There you go.
All right, thank you so much for calling in. I put your name in the apple. All right. Dodge Park is on fire.
Yeah.
I know. Well, what would you like to talk about now?
I thought Jatasia was going to try a challenge.
I
but
think
guess
she's gone.
not. Oh, well.
She's gone. I'm sorry, Jatasia. If you call back in, if you're working on our challenges, please call back in. We would love to have you solve one. Here they are again. 2344 23 22 12 9
4152 and 8624.
There you go. You heard it from Mr. Grubb right here.
Wah, 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 wah.
I know. So what else are we going to talk about now? What other math skills?
You would think that 5th grade we were way past it, but these division problems.
Division? Okay.
People are really struggling with division
Long
problems.
division?
Long
I bet
division.
because they don't know their facts. You have to know your facts.
Yeah, you have to know your facts.
And First in Math is a great program for that, because I know my school is competing for First in Math. We have the top 2 people in the county.
Do you?
Yep. We do. Top 2 individual students are from my school. So if you are out there in Prince George's County, Mathland, watching us, I hope you're on the computer trying to beat us, because we need some great competition. And we do. We have some good competition. They keep neck and neck every day.
You know, some students, they like staying on the computers.
I know. And other
And
people...
they'll go at it and go at it and go at it. And some students are like,
Well,
watch
if you
TV.
practice on First in Math, you will be an expert on these, I bet,
This
because
is
you'll know
true.
your facts.
This
Just
is
the
true.
facts, the gym. You got to
It's
know
stuff that
those
comes
facts.
automatically. I still have
right.
students going like this.
No, you can't solve multiplication problems like that. And then how are you supposed to divide if you can't even multiply?
Yeah, that's the challenge.
Okay, well,
That's the challenge.
what kind of problem do you have for us today? 'Cause
Well-
I know my facts.
I said 376 divided by 3. Now, if you know your divisibility rules, you are on the right path or the wrong path automatically. If you know them, you're on the right path. If you don't know them, then it's going to be a little bit of a challenge. Well, the divisibility rule for 3 is if you add the sum of the digits, and that sum is in the 3 times tables, then this number can be divisible by 3.
Oh, so that means like no remainders then?
No remainders, nothing left
okay,
over.
okay.
So 3 plus 7 is 10. 10 plus 6 is 16. Well, I know 3 times 5 is 15, so I know there's going to be a remainder here.
Absolutely.
So we'll start it off. So how many 3s can we get from 300s? If I have 300s, I can give everyone 100. And I'll share all 3 of them, and I'll have 0 hundreds left.
Right. That's
So
easy.
now I have 7 10s. If I have 7 10s and 3 friends, how many 10s will each person get? Well, each person will get 2 10s. I will share 6 of them, and there will be 1 10 left over that's not shared. And really, division is sharing. That's what I
Sharing.
always
Equal
press upon
sharing.
my
That's all it is.
students. Equal sharing. Sharing the same amount. That's why each of the 3 people got 2 of the 10s, and there was 1 left over that could not be shared. Now, when I bring this 6 down, this 6 is in the 1's place. That 1 10 couldn't be shared, so really what I would do is break those up into 10 1s and put them together with the 6 1s, and I would have 16 1s now.
Oh, now I get it.
That's
okay.
what's actually happening here. So 3 times what number gets me close to 16? That would be 5.
Oh, yeah. Very good. 3 times 5 is 15. I knew that.
And 1 is left over. Now in 5th grade, we don't say remainder 1.
Nope, not in
That's
5th grade.
why it becomes a bit of a challenge. So what we do is we do something called extending the number.
Oh, okay.
So we add the decimal. We put down a 0.
Okay.
Boom.
Oh.
And we also put that decimal right here.
You just keep on going.
Just keep on going. So
breaking
now we
it
look
down.
at that as 10 and say, okay, I know 3 times 3 is 9. And there'll be 1 left over.
Oh, but it's going to keep getting
And
10
then
every
we'll
time.
see 10 every time. And that's a repeating decimal. So we put that little line on top of it because it just keeps on repeating. And then we'll check our work. So 125 and 3/10. It's going to be a little off probably.
Right, because it's repeating. Okay.
So 3 times 3 is 9. 3 times 5 is 15. 6, 7. 3 times 1 is 3. Now this doesn't look like this,
But it's
but
very
what happens
close.
is 375 and 9/10 rounds up to 376.
Right. So if you have math sense, you would know that that's super close.
That's super close.
Super close.
Super 1/10 away.
Right.
And what happens is the more zeros you add and go across, there'll be more 3s there.
And the closer you'll get.
And the closer you'll get.
Wow. Okay. Good to know. Well, I think someone's calling back for a challenge.
Oh, really?
Yes.
Tamawa, back for more?
Hello.
Hello.
Hi. You back for
Hi.
more?
Are you back for another challenge?
Yes.
Okay. Which challenge?
24.
Okay.
You doing the same card?
No.
Okay, you're trying another
Okay.
one.
Different one.
Okay.
All right.
Go for it. Which one are you doing?
D.
D8624?
Yes.
Okay.
Oh, that's a 3
8,
dot problem.
6, 2, 4. I can tell Tamawa likes a challenge. Okay, Tamawa.
All right. 8 times 2 equals 16.
8 times 2 equals 16. Okay, so far so good.
16 plus 6 equals 20.
16 plus what?
16 plus 6
16 plus 6 is not 20.
So close.
It's 22.
Mm-hmm.
Okay. And then what?
22 divided 4 equals 24.
I can't hear you.
I think you're stuck, Tamawa.
Yeah.
All right,
Doesn't
keep
sound
working
right.
on it.
4.
All right, keep working on it, because if you add 22 to 4, you're not going to get 24, but you're very close. Okay? You work on that during the break and call us back, because, Mr. Grubb, it's already time for a break.
Oh, my goodness. Time
All right.
flies when you're having math fun.
I know. So keep working on your math homework. We'll be right back. Okay?
Hello, my name is Jeffrey Greer, and I am here with your email corner of the day. Today we are going to work on adding mixed numbers with unlike denominators. Here's our problem. 5 2/3 plus 3 3/9. What we need to do is find a common multiple of both 3 and 9. The common multiples of 3 is 3, 6, 9. The common multiples of 9 is 9. Stop right there. 9 is a common multiple of both 3 and 9. So we can leave 3/9 alone and work with 2/3. Since 3 times 3 equals 9, we need to multiply by 3. 3 times 2, and we get 6. So now we have 6/9. 6/9 plus 3/9 equals 9/9. Now we need to add the whole numbers. 5 plus 3 equals 8. What we have now is 8 9/9. 9/9 can be reduced. This equals 1. 8 plus 1 equals 9. 9 is your answer. Thank you for joining me of your email corner of the day. Thank you.
You can never know which pool safety step will save a life. Until it does. No matter how safe you feel, adding multiple safety steps can mean the difference between a close call and a call to 911. Simple steps save lives. To learn some new ones, visit poolsafely.gov.
When lending a helping hand to those struck by disaster, we often send help in the form of goods. But did you know how much money goes to the shipping and storage costs for just one of these? It could have been used to provide necessities such as clothing and shelter for so many more people in need of our help and love. The love helps. Send helpful love. Cash is best. For more information, visit www.cidi.org.
And we're back. Welcome back to the second half of the elementary edition. Count on us. I'm Miss Shirey.
I'm Mr. G in the place to be. Call us at 301-772-0080. We have a caller?
We do have a caller. We do. Who's out there? Hello. Welcome to Count on Us.
Yeah, hello.
Hello. Who is this?
Ukamaka and EK.
Oh, well, it's nice to meet you. Have you called in before?
Yes.
Oh, wonderful. So
Hi,
you know
Ukamaka.
all about us.
Ukamaka, what school are you calling from?
John Bain Elementary School.
Wonderful, wonderful. All right, I'm going to put your name in the apple already. And what can we help you with today?
Decimal.
Ooh, decimals.
I'm scared of decimals.
Don't be scared. They're nicer than fractions.
Can I?
Fractions are the bullies.
Okay. All right. What are you doing with decimals, Ukamaka?
But it's a word problem, though.
Okay. That's fine.
Okay, it says, Mr. Scott purchased 4 bats for $12.48.
Mm-hmm.
How much did each bat cost?
Okay, 4 bats at $12.48.
Yeah.
Pretty straightforward problem. Do you know what to do? You know how to set it up?
Yeah.
Okay, so we have our 12 times each bat. All right, 4 times 8.
Which equals 32. So 2, you put the 2 under 4 and 8.
Okay.
And you put the 3 over the 4.
Okay. What's next?
After that, you multiply 4 times 4, which equals 16. Then 16 plus 3 equals, which equals 19. Put the 9 there.
Okay.
Put the 1 over the 2.
Next.
2 times 4 equals 8, and 8 plus 1 equals 9.
Okay. What's next?
Then 1 times 4 equals 4.
Yeah, we're done. What's that, 4,992?
No.
No.
Mr. G.
Oh, what do we have to do?
You have to put the decimal point in the middle of 4992. So you have to put it before the 92.
Before the 9, right there?
No. Yeah.
Right
No. Right.
right there?
Yeah.
Why?
Yeah.
Do you know why?
Yes.
Why?
Because with money, you can't just put the decimal point in front of it. That's not going to make any sense.
Okay, that helps. Well, there's a little rule there. If we have 1, 2 decimal places in the problem, we also need 1, 2 decimal places
No problem.
in your answer. You get it?
Yeah.
So let's say we had $12.48 and it was 4/10. It's a little different, right?
Yeah.
So how many decimal places do we have in the problem?
3.
3. So that means if we treat this as a whole number and skip 1, 2, 3, that changes the place of the decimal.
Yeah.
You understand that?
Yeah.
Seems like you have a good handle on the multiplication. You just were a little trouble with the decimal place, correct?
Yeah.
Okay. Very
But
good.
I like what he said about it not making sense. Because you're right. If they each cost $12 and some change, 4 of them would be 4 groups of about 12.
Right.
So that's about $48. So you're right. If you got the answer of 4,992, that wouldn't even make any sense. You are absolutely right. So that would be a much more reasonable answer. Very good.
Okay.
You've rolled through that. Did you want to try one of our challenges today?
Yeah.
Excellent. Which one?
Can I see? Can I see it?
Yep, here they are. Have you been
Okay.
working on them? We have A, B, C, or D.
I'll take B.
B is in boy.
B, 23, 12, 22, and 9.
That's been a hard one today. Let's see what you got.
I got it. It's in
You
my
got
head.
it now?
I have it. 23,
Okay.
22, 12, and 9.
Okay.
They look scarier than what they really are.
Nope.
Go for it.
Okay. 1, 8, and 12, 13.
What'd you say?
Okay, I'm still trying to do the math. Okay. Let's try 22 minus 12.
22 minus 12, okay? 22 minus 12 is?
10.
10.
Okay. What's next?
Okay. Then after that, wait, I have to think about this one.
All right. well,
Okay. You
why
gonna
don't
call
you
us
keep
back?
working? Yep, keep working on it.
Okay.
All right, I put your name in the apple. It's in here. I'm shaping it up. All right, thank you so much, and keep working on that challenge. And I think we have some more callers.
Chama, are you back?
Yep.
Oh my goodness, I
Yep.
feel like your private tutor.
All right, Tom, what you working on now?
I'm in 24 challenge.
Oh, 24 challenge. Okay, which one?
A.
A?
Yes.
4423?
Yes.
Okay, 4423. Anytime you're ready.
4 times 4 equals 16.
4 times 4 equals 16 all day, every day. You are right. Okay?
16 times
What was that?
16. Take away. Plus 3 equals 19.
16 plus 3 is 19. Yes.
What you gonna do with the 2?
Oh no.
Divide.
Divide. Oh, that's an odd number with a 2. Ooh, that would be kind of
19
messy.
divided by 2? Well, division, is it going to make the number bigger or smaller?
Bigger.
Division?
I mean smaller.
Yeah.
Smaller. So we're trying to shoot for 24. If we're at 19, we don't want to make the number smaller. We want to make the number bigger.
Keep working on that one. All right.
All right.
And Tamawa is working hard.
She is.
All right. Well, we have another caller. Hello. Welcome to Count on Us.
Hi.
Hi. Who is this?
Jatasia.
Jatasia again.
One
All
more
right.
again? Okay.
And what are you working on today?
The 24 challenge.
The 24 challenge. And which one?
D.
D is in dog. 8426?
Yes.
Okay.
All
Go
right.
ahead.
8 times 4 is 32.
This is true.
All day, every day.
32 minus 6 equals 26. 26 minus 2 equals 24.
Oh! I think we have a winner! Yeah! Excellent job. Now I get to write your name in the apple.
Go Jatasia, go Jatasia.
From Dodge Park. All right, I'm going to put your name in the apple again. Thank you so much. You did an excellent job with that one. That was like a 3-dot problem. It was really hard.
Was it?
You must be a good teacher, Mr. G. She got that.
She practices.
Okay.
I don't take credit when they do well.
When they do well. Well, you must be an awesome student, Jatasia. Thanks for calling in. All right, well.
Very good. Pretty good.
Yes, we have some other things to catch up on, though, while we're waiting for our challenge 24.
Really? We do?
Yes, we do.
Doth we?
Yes. We have some more time. I want to get back to time.
Want to get back to time?
Actually, I'm really tired of time because we've been talking about time for a week now, but I still think some of my kids are a little bit rusty on the little nicknames for times. Okay? Yeah, for example, this time, let's say there's the small hour hand. Here's the long minute hand. All right? Do you know what time that is?
Well, I know that the hour hand is pointing directly at 9.
So it's 9 something.
9. And then the minute hand has gone to 1, 2, and 3. And we said earlier that from one number to the next number is 5 minutes.
Right.
So 5, 10, 15. That looks like 9:15, not 3:15. I can see how people can get confused with that being 3:15, but it's really 9:15. Or the nickname is a quarter after 9.
Because remember last time when you cut the clock in half and we said it was half past?
Right.
Well, now when the minute hand only goes to the 3, you're left with 4 different sections of the clock.
And that each section is
like a quarter.
1/4 or a quarter.
Yeah, we call that a quarter. So you're right.
1/4, 1/4, 1/4, 1/4, just like a pizza.
Yeah, like a pizza. So it's quarter after 9.
Right.
That's where they have some trouble with those little nicknames. I call them like the little nicknames because it's another way of saying 9:15. A quarter of the hour has gone around, not to the half. It's half of a half. Okay? Well, great. Now you know that. I hope I taught you something new today.
Cool.
I think we have a caller, though.
Okay.
All right. Hello. Welcome to Count on Us.
Okay, I called in earlier.
Okay, and who is this?
Ukamaka.
Ukamaka. All right. What are you working on?
I want to do first in math.
Okay, the challenge 24.
Ukamaka, turn your TV down, all the way down, and just talk to us through the phone.
It's on. Okay.
That's better.
And which one are you trying?
I'm doing D.
D. All right, you have to do something different than the other caller. 8, 6, 4.
B.
Oh, B.
B. B is in boy. Okay.
23.
I want to see how this one's done.
22.
I want you to solve this one.
12. I have the answer for this one. I have an answer for
All
this one.
right.
Let's go.
Impress
Ukamaka.
us.
I want to do 45 minus... Wait, never mind.
Turn your TV down, all the way down.
Okay. 23 plus 22
is...
Okay.
Equals 45.
Correct.
Okay.
12 plus 9. Equals 21.
21.
Okay.
Okay.
45 minus 21.
Is...
24.
Very good. Excelente. Excelente.
Excellent. Now I have to put your name in the apple again. It's totally awesome. All right.
Wasn't the direction I
Excellent.
was going to go, but it works just the same.
All right. Well, hey, I'm sure there's several ways to solve each of these problems.
It's more than one.
Good job. Excellent work on that.
Excelente.
Your name's going in the apple again, shaking it up, shaking things up a little bit here today. And,
Could be our winner.
Yeah, he could be our winner.
Anyone else out there in TV land? We're
What?
looking.
You're looking?
We're looking.
You're looking? Do you
Where
see
are you?
anyone? Maybe?
I
Maybe?
see you.
Ah, I see them too.
You should be doing your homework.
They're doing their homework. They're just
not
so
the one
smart.
I'm looking at. Not the
No.
one. No.
My kids are doing their homework, and they're just so smart because I just gave them a little mini lesson on time.
Ooh.
So now they know how to do their homework because that's what our homework was on,
Ah.
telling time today. So,
So you're going quarter past, half past, quarter to,
yep,
and all that good
we're
stuff?
doing all that. And that's kind of tricky for second
Very
graders,
good,
but
very
they're
good.
getting it because they're
Second
smart.
grade, yeah.
Oh, yes.
Using little clocks in the classroom, and they're spinning them around.
They made their own clocks. So.
Did they?
Mm-hmm.
Ah.
Yes, yes.
You must have a very fun-filled
Oh,
classroom.
yes. They're very, very, very smart.
Are they good with the cutting and all that good
Yes,
stuff? Huh?
they're very proficient. In fact, you know, we're kind of multitasking in our room because we've also been talking about addition facts, and it might seem like a little bit, easy because some of our callers are calling in about, decimals and everything. But, just a little side note, I wanted to show you about adding nines. There's like a little rule that we found today.
Oh, you did?
Yeah.
Made the 9 discovery?
9 discovery.
Okay.
Okay, and I just review this with my kids all the time because even when kids get to algebra, they just never remember the 0 rule and the 1 rule. Do you know those rules, Mr. G?
Well, I know that if you add 0 to anything,
Uh-huh.
the number stays the same.
It stays the same, so it's 9. Do you know the +1 rule?
And if you add 1 to it, it just jumps up to the next number.
Yep, so 9 plus 1 is 10. Now, after that, this is where we started to find some patterns. Because you can make 10 to add 9. So if I take 1 from here and put it next door, 9 plus 2 is really like 10 plus 1. And the answer is 11.
11.
And if I take 1 from here and put it over here, 9 plus 3 is really like 10 plus 2. And 10 plus 2 is 12. Now, something else we also found. Look at the sum we got. If you add the digits of that sum, 1 plus 1 is 2. 2 plus 1 is 3. So this answer has to be 1 plus 3 is 4. So 9 plus 4 is 13.
That even works for the 10.
It does. 0 plus 1. And it actually works for this one too because 9 can also be written as 0, 9.
This is true.
Yeah, so this has to be 14. 1 plus 4. 4 plus 1 is 5. So 9 plus 5 is 14.
And that keeps going until when?
I don't know. We did all the way up to 9 plus 9 today is 18. 8 plus 1 is 9. 9 plus 10 is 19. 9 plus 1 is 10. I don't think it works after 9 plus 11. 20. 0 plus 2. No, it's not going to work after that. So it just works on your basic facts. But I'm always surprised at how many upper grade kids, 4th, 5th, and 6th grade, do not have that number sense, those little strategies to help you out.
This is true.
So we try to start that early.
Oh, we have another caller.
Hey, caller.
Hi, caller.
Hello.
Hello, who is this?
Mina.
Who is
Hi,
this?
Mina.
Mina, okay.
What school are you calling from?
John Hanson French Immersion.
Oh, bonjour, bonjour, bonjour. And what can we help you with today?
48 ounces equal blank pound.
Ooh, okay.
48 ounces
48 ounces.
equals what?
Blank pound.
How many pounds? Oh. Mina, do you know how many ounces make 1 pound?
No.
16. 16 ounces equals 1 pound. So, we could, what grade are you in, Mina?
Third.
Are you good with your timetables?
Yes.
16 is a little difficult. What we could do is we could keep adding 16 until we get to 48. You want to try it that way?
Yeah.
Okay, so if we add on another 16, that's another pound, and we add those. 6 plus 6?
6 plus 6 is 12.
12. We put down a 2. Carry the 1 because that goes in the 10 place. 10, 20, 30. And 1 pound plus 1 pound equals?
2.
2 pounds. So 32 ounces or 2 pounds. If we add another 16 ounces, which makes another pound, what do we have? 2 plus 6?
Is 2 plus 6 is 8.
Very good. And 30 plus 10?
30 plus 10 equals 40.
Very good. There's your 48 ounces. And 2 pounds plus 1 pound?
3 pounds.
There you go. So 48 ounces is equal to 3 pounds. You see how that works?
Yeah.
Okay. We could, if you're really good with your division, you could just say 48 divided by 16. Now that gets a little tricky too because you have to figure out how many 16s you can get from 48. So that's when you do your times tables and you could say, okay, I know 16, 2 times is 32. Let's try 16 times 3. 3 times 6 is 18. Boom. That's an ugly 8. And then 3 times 10 is 30 plus 10 is 40. So that would be 3. Are you comfortable with division, Mina?
Yeah.
You are? Okay. So you could try it that way. So 48 ounces is equal to 3 pounds. Does that help you?
Yeah.
Very good.
Wonderful.
I'm glad I can help you. Are you going to take on one of our 24 challenges?
Yeah.
You are. Okay.
All right. Which one?
Which one do you want?
Challenge B.
Challenge B.
You said B?
Yeah.
Ooh.
Oh, we've already had a solution for
We
that.
have a solution. You're going to have to give us one that's different. You think you have a different solution?
Yes.
Okay. Let's see. Show us what you have. 23, 22, 12, and 9. What do you have for me?
12 plus 9 equals 21.
This is true.
22 minus 21 equals 1.
Okay.
1 plus 23 equals 24.
Excellent. That was different.
Woo!
Yeah. Mina, you and I think alike. I had that problem solved the exact same way. Cool.
Very good.
Your name goes in the apple 2 times. 2 times. Not once. Twice.
I have to
Let's
get
hear
more
for
paper. We've had so
John
many
Henson.
callers. I need to get another piece of paper.
Oh my goodness.
It's excellent.
Very good.
All right, well,
very
we have
good.
more callers. Hello.
Next.
Hello.
Tamwa, are you back for more?
Yes, I am.
Tamwa.
Hello. What are you working on?
Huh?
What are you working on? What would you like us to help you with?
The 24 challenge.
Okay.
Which one?
I will pick a B.
B?
B? Well, we already had 2
We already had
solutions
that.
for B.
Oh, I mean C.
C? 4152? Okay. What do you have?
I have 2 times 4 equals 8.
2
This
times
is
4
true.
equals 8.
Okay.
8 times 5 equals...
I think that's going to be too high.
8 plus 5.
8 plus 5.
Okay. Is what?
13.
Okay. And you have a 1 left.
Now it's too low.
Ooh, yep, now it's way too low. All right, Tom, well, call us back, okay, when you figure out the answer. You only have a few more minutes left in the show, and we want to get to the other callers, so keep working on that, okay? All right, who else is next?
Jatasia?
Hello?
Abriana?
Hello?
Hello. Who is this?
Brianna.
Oh, hello. And what grade are you in?
4th grade.
And what school are you calling from?
Forest Mills Elementary School.
Oh, very nice. Okay, and what can we help you with today?
I wanted to try one of your challenges.
Okay.
You didn't give us a problem to work on. You have to give us a problem before you get to the challenge.
2,700 divided by n equals 30.
2,700
Yes.
divided by?
N equals 30.
Oh, divided by n equals 30. Okay. Well, that's not so bad because that's a pattern problem.
Divided by n equals 30? Oh, okay. Well, Abriana,
Yes.
do you know your 3 times tables?
Yes.
If we take off these zeros here, 3 times what number gives you 27?
9.
9. So, if n is equal to 9, 30 times 9 is going to give us 270. But we need one more 0. So, what do you think we should do?
Add a 0.
Very good. So, if I usually put the big number on top. 90 times 30. 0 times 0?
0.
Ba-dum. 0 times 9?
0.
Boom. 0 is a placeholder. We're finished with this column. Now we have 30 times 0?
0.
0. And this is, we always say 3 times 9, but that's really 30 times 90. And that's going to give us that big number, 2,700. You see how that works?
Yeah.
So if you know your math facts, don't even worry about these zeros until you get your answer. So you can, this is like front end estimation. So I know 3 times some number equals 27, that number is 9. But I need 2 zeros in there. So 1 0 in the 30 takes care of that. I need another 0 after that 9. You see how that works?
Yeah.
Does that help you?
Yeah.
Very good, very good.
Wonderful.
Now you can take on one of our challenges. You ready for a challenge?
Yes.
Which
Okay.
one? Here they are.
You ready?
Yes.
Which one do you want?
A.
A.
Okay.
2, 3, 4, 4.
2, 3, 4, 4. Give it to me.
4 times 3 equals 12.
Okay. 4 times 3 equals 12. Good start. Good start.
4 plus 4 times 2 equals 8.
Ooh. What now?
Oh, that's wrong.
Oh, you were close. You were close. Good try. Good try.
You can call back during the next show. We are about to go off the air. We will start the next show in a couple of moments.
Just a couple of moments. We
Just
have to hurry
a couple
up.
of moments.
We got to pull our
we
winner.
need a winner. We need a winner. We need a winner today. We need a winner today.
Okay,
and the winner
who
is
is
Nina.
Nina, you're a winner! Yay! Nina, congratulations. Please, all the callers, please
young
hold
lady for
on.
French.
We just have to do one commercial break, and then we'll be right back. And all those
be
people
back.
that are still on the line,
You can call back.
We will help you.
Stay there,
all right?
Chris. Stay there, Jatasia.
Well-
We'll be right back.
All right. Well, it's been a pleasure, Mr. G. It's always awesome working with you because remember, you can always count on us.
Hi, welcome to the Count on Us mini lesson of the day.
I'm Ms. Shirey. I'm going to talk to you today about place value. Let's look at our problem. Place value, a mini lesson on the value of numbers. Our objective for today is students will use place value blocks and a place value chart in order to understand the value of numbers. Here we have a problem. It says Ian and Olivia were trying to decide who had more baseball cards. Ian has 4,237 cards. Olivia has 4,327 cards. Their friend Sammy said that they each had the same since all the digits were the same. Was Sammy right? Let's take a look at a place value chart to help solve the problem. Sometimes a chart like this can help. Ones, tens, hundreds, thousands. If you put the digits in each of the place value places, we can tell who has the larger number. Here's Ian's number, 4,237. Here's Olivia's number, 4,327. Look in the highest place, then keep going. You can see they both have a 4 in the thousands place, but look, Ian only has 2 hundreds, Olivia has 3. Let's look at it with a place value blocks. Here's a picture that shows you 4 thousands, 4 thousands. They're the same, but you can see Ian only has 2 hundreds, where Olivia has 3 hundreds. You can see by the place value blocks that Olivia has more blocks than Ian. Each place really does have a certain value. Sammy wasn't right on this problem. Well, thanks for watching. We'll see you next time on our Count on Us mini lesson of the day.
Hello? Hello? I've been on the street for a while. I saw your poster outside. I don't know what to do.
National Runaway Switchboard, how can I help? Call 1-800-RUNAWAY to make the connection.
You have the time to give. You have the capacity to care. You have the experience to contribute. And your country needs you, one of its greatest assets. Americans whose lifetime of knowledge and know-how will make the difference. Take what you learned in the workplace and apply those skills to your community. Shape tomorrow by being a mentor and tutor for children. Make independence a reality for people who need assistance and companionship to continue to make their house their home. Make a difference today. Get involved.
What's happening? It's your Royal Hypeness, Angie Angel, your Mike 93.9 WKYS is my radio station, 6 to 10 p.m. Check me out. And when I'm having problems with my math, I call in to Count on Us. I can always count on them.
Because how many ways are there to solve math?
Many! Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is
2 times length plus 2 times width.
And welcome to your Telly Award-winning math homework hotline, Count on Us. I am Mrs. Davis here with my fabulous partner.
I'm Mr. Belton. Welcome to Count on Us.
We are here to help you with any math homework that you might be having. You can give us a call at 301-772-0080. If you have Comcast, that's channel 96, Verizon, channel 38. And if you do not have Comcast or Verizon, but you're watching via the internet, at www.pgcps.org. We're here to help you with any math homework questions. And after you've had an opportunity to answer a question, we are going to challenge you with our 24 challenge. The way that this works, Mr. Belton will explain.
We have 4 options here. Card A, we have 14, 9, 3, 2. Card B, we have 7, 5, 4, 1.
Oh.
Card C, we have 8, 7, 6, 2. And lastly, card D, we have 2 8s, a 5, and a 2. Remember, boys and girls, you want to use all 4 numbers only one time, and you want to produce a result of 24 using any combination of the 4 operations.
Add, subtract, multiply, and divide. And remember, if it's shaded in red, this is a 9. This is unshaded, so it is a 6. So please go ahead and jot these down. So after your question, you can challenge yourself with 24 challenge. We also have a word scramble here, and I'm going to give you a hint. It is something to do with geometry. Is that a good hint?
That is.
That is a good hint. Something to do with geometry. So once you've had a chance to answer the question, you can challenge yourself with the word scramble or the 24 challenge. And we really appreciate our callers who've been waiting so patiently. Thank you, thank you, thank you. And so we'll get right to their call. Chris, are you there? Chris? Hello, Chris.
Hello.
Hi, Chris. Welcome to Count on Us. Are you calling from Andrew Jackson Academy?
Yes, I am.
All right. And what grade are you, Chris?
I'm in 5th grade.
5th grade. And who is your math teacher?
My math teacher is Miss Williams.
Well, please tell Miss Williams and all of your classmates at Andrew Jackson Academy we said a big, big hello from Count on Us. Now, what question are you working on in 5th grade math?
Well, to be honest, I'm really not that good with division, and my problem is...
So you're working with division, is that correct?
Yes.
Okay. Division can be tricky. Division can be tricky for a lot of students. So the key is to know your multiplication facts, your division facts, and you even have to know how to subtract and add. So division does cause a lot of students some difficulty, but we're here to help you. So if you'll go ahead and give me your problem, I'll write it down and we'll see if we can work it out together. How does that sound?
That sounds like a great idea.
All right, you have called the right place. All right, Chris, what problem are you working out?
My problem is 3 divided by 28.
Your problem is, repeat it one more time, please.
3 divided by 28.
3 divided by 28. Okay, Chris, take a look at the screen and see if I have written what you said. You told me 3 divided by 28. Is that what you meant?
Yes.
Okay, 3 divided by 28. If you're using the paper and pencil method, we would also think of this as 28 divided into 3. Is that what you meant?
Yes.
Okay. Well, Chris, in order to solve this problem, we can think of this also as we can also think of it in fraction form. Here, if I only have 3 things, can I get a group of 28?
A little.
If I only have $3, can I buy something that costs $28?
No.
No. So that lets me know that I'm going to be working with either in decimal format or fraction. Which did your teacher ask you to do? Write it as a decimal?
Yes.
Okay, very good. All right, so let's go ahead and think about our 28 multiplication facts. Remember I said in order to divide, you have to have your multiplication facts mastered. So if I only have 3 things, $3, I can't get a group of 28, so I'm going to put a 0 in my quotient. And I'm going to annex a decimal point, and the decimal goes straight up in my answer as well. So now I'm going to continue to annex zeros until either I notice a pattern of repeating or I get a remainder of 0. Okay? Does that sound fair?
Yes.
Okay, so now we're thinking about this as just 30. If I have $30, can I buy something that costs $28?
No.
If I have $30, can I buy something that costs $28?
Excuse me, can you repeat that again?
If I have $30, can I buy something that costs $28?
Yes, you can.
Yes, I can. How many things can I buy?
You can buy one.
1. Because 28 times 1 is 28. So I'm going to put my 1 times 28, write my product here, and subtract. Now I am going to continue subtracting. If I have 0, can I subtract 8? 0, subtract 8. I'll need to regroup, yes?
Yes.
Okay, 10 minus 8 is? 10 subtract 8 gives me 2. Do you agree?
Yes.
Yes. Okay. Or I can think if from 28 if I want to count up to 30. 28, say 28, 29, 30. It's only 2 away. Now I have a remainder. As long as my remainder is less than what I'm dividing by, I'm okay. Now remember when we're working with decimals, we said we're going to continue dividing until we see a pattern of repeating numbers or get a 0 as a remainder. Or we could be told to divide to a certain decimal place. Okay, so let's put 20 here. Annex another 0 and bring it down. If I only have $20, can I buy anything that costs $28?
No.
No. So I'm going to put a 0 up in my quotient. And 0 times 28 is 0. Subtract. Bring down my 20. So now I have a remainder of 20. I am going to annex a 0 and bring it down. Now, if I have $200, can I buy some things that cost $28?
Yes.
Okay, about how many things do you think we can buy?
I think you can buy about...
Shall we try about 7? Let's try 7. Okay, 7 times 8 is?
7 times 8 is...
56. 56?
Yes.
7 times 2 is 14 plus 5, 19. Is that correct? So we're going to put 7 up in our quotient. 7 times 28 is 196. Subtract. And I have, right here, I'll regroup. This becomes 10. Regroup. This becomes 9. Regroup. This becomes 10. 10 subtract 6 is?
10 subtract 6 will be about 4.
Yes. Okay, so we still have a remainder, so we're going to continue to divide one more time. Now, did your teacher tell you to go to a specific decimal place?
No.
Did she say round to the nearest tenths, hundreds, or thousands?
Yes, we were rounding to the nearest 10.
The nearest tenths? Okay. Well, if we're rounding to the nearest tenths, we can actually stop here. Because when we're rounding to the tenths, our first place behind the decimal is tenths. And we're going to look to our hundredths place to tell us whether we're going to round up or round down. So you can think of this as high 5, mean we're going to increase, or low 4, 4 or less, we're going to decrease or round down. Decrease or round down. So if it's 4, we're going to round down, which means this actually stays the same. So I'm comparing this 0 to 5. Is it more than 5 or less than 5?
It's less than 5.
It's less than 5. That means I'm going to round down. When we're working with decimals, rounding down simply means I'm going to let my tens place remain the same and I'm dropping everything else off. So here, 3 divided by 28 is equal to approximately 1/10, since we are rounding. Does that help? And I'm going to say approximately equal to 1 ton. Okay. Chris, thank you so much for your call. If you have any additional questions, you are welcome to give us a call back. We do have a couple other callers waiting on the line, and we do appreciate their patience. So give us a call back, Chris, if you have any additional questions. And I think we're ready for our next caller.
Next caller, are you there?
Hello?
Hi.
Caller, are you there?
Yes.
Is this Christine?
Yes.
Christine, what school do you attend?
Gwen Park Middle School.
Gwen Park Middle School. Hey.
Gwen Park is representing. Let me shake for Chris from Andrew Jackson Academy. All right. We really appreciate all of the schools that are being represented here this afternoon. So remember, you can give us a call if you're having any questions with your homework.
Christine, do you have a question? How can we help you this evening?
I have a question on solving and graphing inequalities.
You have a question on solving and graphing inequalities?
Okay, and I'm going to write for Mr. Belton.
Thank you,
And
Ms.
I'm going to
Davis.
attempt to spell solving and graphing. Okay. Inequalities, you said?
Yes.
Okay.
Okay, Christine, what's your question? Do you have a specific question?
Yes. It is R minus 1 2/10 less than negative 0 5/10.
Okay, Christine, do me a favor and turn your TV down. You said R minus 1 2/10 less than negative 5/10?
Yes.
Okay. Now, when we solve inequalities, Christine, we do what we call the inverse operation. And we do that to both sides of the inequality so that the inequality remains true. Now,
I meant greater than.
greater than?
Yes.
Okay. Now, when we're isolating our variable, in this particular inequality, what's on the same side as our variable that we need to get rid of or cancel out?
The the 1 2/10.
The 1 2/10. Right now, the 1 2/10 is being subtracted. What's the inverse operation of subtraction, Christine? Do you know?
Adding 1 2/10.
Adding 1 2/10. Now, we want to do that to both sides of our inequality. Adding 1 2/10 to both sides. Now, on the left side of our inequality, what happens to our minus 1 2/10 plus 1 2/10?
You cross it out.
That cancels out because that's equal to 0. We no longer need that. We bring down our variable. We bring down our inequality symbol, the greater than symbol. And now we have a negative 5/10 being added by 1 2/10. Now, Christine, are the signs the same or different?
Different.
When our signs are different, we do what?
Subtract.
We subtract. Now, when we subtract 5/10 from 1 2/10, we get
9 3/10.
not 9 3/10. We want to subtract the 5/10 from 1 2/10 to get 7/10. Now, that 7/10, is that 7/10 going to be positive or negative?
Positive.
Why is it going to be positive? That's correct, but do you know why it's going to be positive?
Because 1 2/10 is greater.
Because 1 2/10 has the greater absolute value. That is correct. Now, we have our result. We have our inequality. Now we're ready to do what?
Graph it.
We're ready to graph it on a number line. So, we have 7/10. Since that is part of our inequality, we're going to place 7/10 in the center of our inequality. Now, if we are increasing our scale in increments of 1/10 to the right of 7/10, we're going to have what value to the right of 7/10?
0.0 and 6 tenths.
To the right of 7 tenths?
0 and 8 tenths.
0 and 8 tenths. And to the left of 7 tenths?
0 and 6 tenths.
0 and 6 tenths. Now we're ready to graph. Hopefully you have your chart handy. Our symbol is greater than. So we're going to place a circle above 7 tenths on our number line. Is our circle going to be open or closed?
Open.
Open, because we cannot include 7 tenths in that solution set because 7 tenths is not greater than itself. We want to shade everything on our number line that's going to be greater than 7 tenths, which is why we cannot shade the circle in, because 7 tenths is not greater than itself. Now, what direction am I going to shade my number line? Remember, the inequality is greater than. What direction?
Shade right.
We're going to shade right. So I want all my numbers on my number line to the right of 7 tenths, representing that those are the numbers that satisfy my inequality, meaning they are greater than 7 tenths. Does that help you out?
Yes.
Okay, Christine, we have a few callers after you. So would you like to try a 24 challenge?
Yes.
Okay, we're going to show you the card.
And Christine, we're going to ask you and all of our listeners if they'll go ahead and jot one of these down and go ahead and have a solution and give us a call right back to solve a challenge. Okay, Christine, have you had a chance to jot them down?
Yes.
Okay, well, give us a call right back, okay?
Okay.
All right,
Thank
good
you.
job.
And we have another caller waiting for some math homework help. Okay, you comma?
No.
Okay, say it for me. I'm sorry?
Ukamaka.
Yukamata. Oh, what a very nice name. Yukamata. And you're calling from John Bain, is that correct?
Yeah.
All right. And who is your teacher at John Bain?
Miss Suggs.
Well, please tell Miss Studs?
Miss Suggs.
Miss Sebs.
Suggs.
Suggs, and all of your classmates, we said a big hello from Count on Us. And what are you working with in class?
I'm working with order of operations.
Order of operations. Okay. Is there a particular problem that you need some help with for order of operations?
Yeah.
Okay. Which problem?
5 plus 5 plus 5.
5 plus 5 plus 5?
Yeah.
Okay.
Okay. Divided by 3.
Divided by 3.
That's 2.
Plus 2?
Yeah.
Okay.
Multiplied by 3.
Multiplied by 3. And what grade are you? Yukamata?
5th.
5th grade. Okay. Any parentheses? Have I written this problem correctly?
The parentheses are on the beginning of the 5 and the last part of the 5.
So all 3 of these 5s are in parentheses. Is that correct?
Yeah.
Okay. So 5 plus 5 plus 5. So adding 5 3 times divided by 3 plus 2 times 3. All right. Is that correct?
Yeah.
Okay. Now, the way that order of operations work, it lets us know which operation to do first when we have a combination. Okay? So if I'm looking here, P stands for parentheses. Do we have any parentheses in this problem?
Yes.
Okay, so we're going to work inside of the parentheses until we have satisfied it, working from left to right. What's 5 plus 5?
10.
And what's 10 plus 5?
15.
Okay. And we're going to rewrite everything we have not used. Okay, 10 plus 5 is 15, so we're rewriting. Divided by 3 plus 2 times 3. So we have taken care of parentheses, and I like to just put a little check mark next to it to keep myself organized and straight. So I've used my parentheses. Next thing, we have E. E stands for exponents?
Yeah.
Okay, do we see any exponents in here? Do you see any exponents?
No.
No. Okay, so let's go ahead and we've taken care of that. Now I have an M and a D, and I like to put arrows with my M and a D because we're going to do multiplication or division in order from left to right. Okay?
Okay.
All right, so let's look at the problem carefully. Here we have division, addition, multiplication. Which one are we going to do first?
Division.
Division. Even though we have MD for multiplication division, it's going to be from left to right. So we're going to do division first. So we have 15 divided by 3. What is 15 divided by 3?
5.
5. Rewrite everything that we haven't used. Okay, so we can check off can we check off multiplication and division?
Yeah.
We did division, but let's look carefully. We have which two operations remaining?
Multiplication.
Addition and
Multiplication.
multiplication. So which one should we do next?
We should do multiplication.
Multiplication. Remember, we're going in order from left to right based upon our order of operations. So even though addition comes first, according to my order of operations, I must do multiplication or division first. Okay, so we're going to put multiply 2 times 3. And help me out. What is 2 times 3?
6.
6. And now we're going to rewrite everything we have not used, and we're ready to go to our final level, adding or subtracting. Which one do we have?
Adding.
Adding. And what is 5 plus 6?
11.
11. So according to order of operations, our final answer is 11. Okay? Does that help? Does that help?
Yeah.
All right. Very good. Thank you so much for your call. And we do have a couple more callers, so if you'd like to do one of our challenges, will you do me a really big favor and give us a call right back?
Okay.
Thank you. All right, and your name is going into the apple for a chance to win a fabulous prize at the end of the show, so please stay tuned. And I think we have another caller from Gwynn Park. Gwynn Park is representing, and John Bain is representing. All right, so here we go. We have, is our caller from Gwynn Park? Is this Essence?
Yes.
Hi, Essence. Welcome to Count on Us. Are you a first-time caller?
No.
All right. And who is your math teacher?
Mr. Belton.
Mr. Belton's class is representing. Okay.
How can we
I
help you
wonder if there's any other students whose teachers are on the show they're going to represent as well. Okay, Essence. I'm going to write, and I'm going to stop cutting Mr. Belton off. I'm going to write, and you can go ahead and tell him your problem.
Okay, 3 and 5/10.
Okay, what are you working with?
Solving equality.
Solving
inequalities. Inequalities, Essence.
Yes.
Okay. Did you see our previous caller?
Yes.
Okay. So. Okay. Go ahead. I'm writing.
What's your question, Essence?
Okay, 3 and 5/5.
3 and 5/10.
No. Yeah.
Okay.
More than greater. More than, but it has like a little dash under it.
Oh.
Greater than or equal to? That?
Yes.
Okay. Z.
Plus 2/5.
You said 2/5?
2 and 5/10.
Oh, okay. 2 and 5/10. Okay. Now.
Okay. Did I write it correctly?
2 and 5/10 instead of.
That's correct.
2 and 5/10.
2 and 5/10 is a fraction.
Oh.
And so is 3 and 5/10.
So it's written are they written as mixed numbers?
No, they're just fractions.
Okay.
No, it's just 3 over 5.
That's 3/5, not 3 and 5/10.
Oh.
Okay.
Okay.
All right. So
we got it fixed. So
3/5 is greater than Z plus
2/5.
Yes.
Okay. There we go.
All right.
Is that it now?
Yes.
Are you watching?
Uh-huh.
Okay, now, what we want to do, Essence, we want to isolate our variable. That means we want to get our variable by itself. So, going back to our inequality, what do we see on the same side of the inequality as a variable that we need to cancel out or get rid of?
The z, the coefficient.
Well, we need z. That's our variable. What do we see on the same side as our variable that we need to get rid of or cancel out?
2/5.
2/5. Right now, the 2/5 is being added. When we isolate our variable, we do so by performing the inverse or opposite operation. What's the opposite of adding 2/5, Essence?
Subtraction.
Subtraction. So what we want to do is we want to subtract 2/5 from both sides of our inequality. We do that on both sides to keep the inequality true. Now, on the right side, what happens to our 2/5?
It cancels each other out.
They cancel out because that's equal to 0. We bring down our variable. We bring down our inequality symbol. And we subtract on the left-hand side. Essence, what's 3/5 minus 2/5?
1/5.
1/5. Now, looking at the inequality the way we see it currently, it may look somewhat confusing. So what we're going to do is we're going to rewrite it so that the variable comes first from left to right. So reading it the way we have 1/5 is greater than or equal to z. We can also write that as z being less than or equal to 1/5. You see that?
Yes.
Notice that the smaller portion of the alligator still faces the variable, but we just want to rewrite it from left to right so our variable comes first. Do you also have to graph the inequality?
Yes.
Okay, so we're going to place 1/5 in the center. Now, Essence, to the right of 1/5, we're going to have what?
3/5.
But before 3/5, we'll have
2/5.
2/5, then 3/5. Okay. To the left of 1/5, we're going to have
-2/5.
not negative, not first. Going backwards. Look at the numerators. We have 3, then 2, then 1.
0.
0 over 5, which is just better known as 0. Then we would have -1/5. Then finally -2/5. Now, going back to our graph. First thing we want to do is place a circle above 1/5 on our number line. Now, Essence, is that circle going to be open or closed?
Open.
You sure? Look at the symbol again. We have less than or
Closed.
equal to.
Closed.
So our circle is going to be closed because the reason why we shade in our circle is because if z is 1/5, this is a true statement, meaning 1/5 is less than or equal to itself. So we have to include 1/5 in our solution set, and we do that by shading the circle in above 1/5. Now we have to take care of the less than portion. On a number line, when you're dealing with the inequality symbol less than, what direction do you shade?
To the right.
You have your chart?
Yes.
Are you looking at it?
No.
Okay, when we have less than, we don't shade to the right. We want all the numbers that are less than 1/5. If we look to the right of 1/5, 2/5, 3/5, are those numbers less than 1/5?
No.
No, so what direction do we want to shade?
Left.
We want to shade left. All of those numbers are less than 1/5. Does that help you out, Essence?
Yes.
Okay, thank you for calling.
All right. All right. Essence, thank you so much for your call. And for those students that are on the line, we're going to take a quick break.
Please hold on. Don't hang up.
Please hold on.
We'll be right back.
Tamara and our other students that are holding on the line will be with you in a second, Christine, on the other side of the break.
is Jennifer Greer, and I'm here for today's email corner of the day. Today I will show you how to do elapsed time. How can you calculate elapsed time? Here are two clocks. One shows when the party started at 10:10. The other shows when it ended, which is 12:45. First, count the hours. Start at 10:10, 11:10, 12:10. That's 2 hours. Next, count the minutes. 12 start at 12:10, 12:15, 12:20, 12:25, 12:30, 12:35, 12:40, 12:45. That's 35 minutes. Finally, put it all together. 2 hours and 35 minutes. Thanks for joining me for today's email corner of the day.
There is a country in Europe, Iceland, which has been called the perfect eco-island because it is a place of clean air, fresh water, and natural beauty. Reykjavik, the capital city, radiates pure energy and a thriving culture. Geothermal steam heats homes and pools throughout the city. Iceland offers many opportunities to get re-energized. This is Iceland. Luminous, captivating, unforgettable, beautiful. Come see for yourself.
Many good things are easy to spot, even in black and white. A maple leaf, birds in flight, our trees in summer. But there's one bad thing that's also easy to spot because it is black and white. The Asian longhorn beetle. This insect is killing our trees, but with your help, we can defeat it. It's as simple as black and white. Look for the beetle, and if you spot it, report it at beetlebusters.info.
You can never know which pool safety step will save a life. Until it does. No matter how safe you feel, adding multiple safety steps can mean the difference between a close call and a call to 911. Simple steps save lives. To learn some new ones, visit poolsafely.gov.
And welcome back to the second half of your Telly Award-winning math homework hotline. Count on us. We've had such a fabulous first hour. We can't wait to wind up the second half hour. So I am Mrs. Davis here with my fabulous partner.
And I'm Mr. Belton. Welcome back, ladies and gentlemen.
We are here to help you with any math homework questions you may have. So give us a call. The number is 301-772-0080. And we really appreciate all of our callers. You've been so patient. So let's get right to it. I do think we have Tamara calling from Stephen Decatur. Is that correct?
Yes.
Hello, Tamara. And can you tell me who is your math teacher at Stephen Decatur?
Mrs. Davis.
Mrs. Davis! Well, Tamara, how can we help you with your math homework this afternoon? And Mr. Belton, I will be writing and Mr. Belton will be explaining, if that's okay.
Okay, Tamara.
Yes.
What are you working with?
I'm working with fractions.
Fractions.
All right.
What are you doing with fractions? What operation?
I'm adding them.
Adding fractions. All right. What is your question, Tamara?
1/12 plus 3/4.
1/12 plus 3/4. Now, what you have are you have two fractions that have unlike denominators. When we add fractions with unlike denominators, Tamara, do you know the first step?
You have to make them. You have to have a common denominator.
You have to find the common denominator. Do you know the least common denominator between 4 and 12?
12.
It is 12. Very good. So, before we do any adding, we have to make sure our denominators are common. Now, the least common denominator between 4 and 12 is 12. So now we have to undergo a process called renaming our fractions. Now, if you look at the first fraction, Since our denominator was already 12, we don't have to rename that particular fraction. We could just bring the 1 down, and we have, in essence, renamed that fraction already. Now the second fraction. The denominator was originally a 4. Now it's a 12. Tamara, what do we do to that 4 to get a 12? Multiplied it by 3. In order to keep our fractions equal, whatever operation we perform to the denominator, we have to also perform that operation to the numerator. So if we multiply 4 times 3 to get 12, we also need to multiply 3 times 3, and that gives us, Tamara? That gives us 9. Okay, now we are in a position to add our fractions since the denominators are the same. When we add fractions with the same denominator, we keep that denominator the same, and we add our numerators. Our numerators are 1 and 9. When we add 1 and 9, we get 10. Now, does Miss Davis require you all to simplify fractions?
Absolutely. Yes.
Okay, so we have 10/12, but we know that can be simplified. What can we divide both 10 and 12 by in an effort to simplify our fraction?
2.
Okay, we divide both again, perform the same operation to both the numerator and the denominator, which keeps our fractions equal. 10 divided by 2 is 5, and 12 divided by 2 is 6. So our fraction in simplest form is 5/6. Tamara, are you there?
Yes.
Okay, does that help you out?
Yes.
Would you like to try a 24 challenge?
Yes.
Okay.
So, Tamara, we're going to ask you to give us a call right back to try a 24 challenge. We do have one other student that's on the line for some math homework help. Thank you so much for your call, Tamara. All right, we have another caller that's calling with some math homework help. Is that correct? Is this Kara?
Christine.
Christine?
Yes.
Hi, Christine. Thank you for giving us a call back. You wanted to do the 24 challenge. Is that correct?
Yes.
All right, so there are our 4 numbers. And remind all of the people who may not have done 24 challenge how it works.
You have to add all 4 numbers to get 24, but you can't repeat the numbers.
Okay, so which card would you like to do?
B.
I'm sorry?
B.
B as in boy, 7154. Is that correct?
Yes.
Okay, so we are doing a 24 challenge. 7, 1, 5, and 4. Okay, go ahead. Let's see if you can meet the challenge, Chris.
7 times 4 is 28.
7 times 4 does equal 28.
Minus 5.
28 minus 5 is how much?
23.
23. We've used our 5.
Plus 1 is 24.
Plus 1 is 24.
Very good, Christine. Very
Way
good.
to go. Very, very good. So, Christine, your name went in one time for calling with a math homework question. It's going in a second time for completing a challenge. So please stay tuned to the end of the show to see if you are one of our winners of a fabulous prize. And we do have one more caller. Kyra. Hi, Kyra.
Yes.
Welcome to Count on Us. And what school do you attend?
Stephen Decatur.
Stephen Decatur.
Representing. All right. Kyra. And who is your math teacher?
Mrs. Davis.
Mrs. Davis.
Mrs. Davis. Hey.
Mrs. Davis' students are representing this afternoon. Thank you for your call. And Kyra, can you please tell Mr. Belton what you're working on?
Fractions.
Fractions. And Kyra, we're going to ask you to turn your television all the way down and just listen to us through the phone. Is that good?
Is that good? Yes.
Okay. Because I can hear the echo in the... Okay. Thank you. All right. And you're working with fractions?
Yes.
Okay.
Kyra, what are you doing with the fractions? What operation?
We are adding.
You're adding fractions. Okay. What are your fractions, Kyra?
2/5 plus 5/10.
I'm sorry, you said 3?
2/5 plus 5/10.
2/5 plus 5/10.
Yes.
Okay. Now, when we add fractions, Kyra, with different denominators, there's something we have to do before we add. Do you know what that is?
Find the least common denominator.
Find the least common denominator. That is right. Now, our two denominators are 5 and 10, so we need the least common denominator between 5 and 10. Do you know what that is?
10.
10. So, we want to place 2 10s, because that is our new denominator. Now, Kyra, if you look at the second fraction, the denominator was originally a 10, so we do not have to rename that fraction. We can just bring our 5 down, and we're ready to rename the first fraction. Now, the original denominator was 5. Now it's 10. What did we do to that 5, Kyra, to get 10?
Multiply 2.
Multiply by 2. Whatever we do to the denominator, we must also do to the numerator to keep our fractions equivalent. Now, 2 times 2 is?
4.
4. Now we are in a position to add our fractions since our denominators are the same. When we add fractions with the same denominator, we keep that denominator and we just add our numerators. So 4 plus 5 would be?
9.
9. And our final answer is 9/10. Does that help you out, Kyra?
Yes.
All right.
Very good job.
Kyra, excellent work. Thank you for your call. And if you would like to do a challenge, we're going to ask you to give us a quick call back. Is that okay?
Yes.
All right. And I think we do have another caller that is waiting on with a 24 challenge. Is this
Joshua?
Oh, okay. So we have another caller. Is this Joshua? Is this Joshua?
Yes.
Hello, Joshua. And can you tell us which school you're calling from?
Stephen Decatur.
Stephen Decatur is representing. All right.
Stephen Decatur portion of the show, I guess.
The Stephen Decatur portion of the Math Homework Hotline. And we're welcome helping students from any school in Prince George's County, so you can tell your friends if they would need some math homework, they can count on us at the show. Joshua, are you working with adding fractions as well?
Yes.
All right.
Okay, Joshua.
Okay, so we're adding fractions. Did you see Tamara and Kyra's question? Joshua, did you see Tamara and Kyra's question?
No.
Oh, okay. Well, they were just on the show with the adding fractions question. So go ahead and give us yours, and we'll do our best to help you. Is that good?
Yeah.
All right. Go ahead and give us your problem.
1 1/4.
1 1/4.
Plus 1/3.
Plus 1/3. Okay. So this is actually, we have a mixed number here and a fraction here, but we still follow the same procedure. We're going to look at our denominators. Okay, Joshua, I'm looking at my denominators. Are they the same?
No.
No, they are not. So before we can continue, we must find a common denominator. So we're going to write our denominators, 3 and 4. And this is a little mini multiplication chart to help us find our denominators, okay? Okay, so we're trying to find a common denominator between 3 and 4. Okay, so 3 times 1 is?
3.
1 times 4 is? 1 times 4 is 4. Okay, 3 times 2 is?
6.
2 times 4 is?
8.
Okay, we haven't found a common denominator yet, so we're going to keep on going. 3 times 3 is?
9.
3 times 4 is?
12.
3 times 4 is? 12. And we have found our common denominator. We have found our common denominator, Joshua.
Yay.
Our common denominator is?
12.
12. Okay, so we're going to use the fraction portion to rewrite as denominators of 12. Okay, what do we multiply times 4 in order to get 12?
4 times 3.
4 times 3. So we're going to have to do the same thing to our numerator. 1 times 3. So 1/4 is equivalent to 3/12. So this is 1, bring down our whole number, 1 and 3/12 plus. Now what do we do to our 3 to get a denominator of 12?
We times it by 4.
Very good. And if we do that to the denominator, we must do it to the numerator. 1 times 4 is?
4.
4. Okay, now that we have common denominators, they match, we can add our numerators. Our denominator stays what?
The same.
Which is?
12.
12. We're going to add 3 plus 4. 7. And we're going to keep our whole number. So our final answer is?
1 and 7, 12.
Very good job,
Joshua. Does that help?
Yes.
Okay, very, very good. Thank you for your call.
Okay.
Okay.
Next caller.
And we do have
Candace.
Yes.
Are you there?
Yes.
Okay, how can we help you this evening?
Adding fraction.
Okay,
fraction.
What are your two fractions? What grade are you in, Candace?
6.
6th grade, and you attend Stephen Decatur?
Yes.
All right.
Stephen Decatur is representing.
Okay, what are your two fractions, Candace?
1/12 plus 3/4.
1/12 plus 3/4. Okay. Now, Candace, were you watching the show earlier?
No.
Okay, we have different denominators. So the first thing we need to do is find the least common denominator between 4 and 12. Do you know what that is?
No.
It's 12. So what we're going to do is we're going to keep our first fraction the same, 1/12. And we're going to rename the second fraction from 3/4 to 9/12. Multiplying the denominator as well as the numerator by 3. So that second fraction will become 9 out of 12. Now, when we have our denominators the same now, we keep our denominators the same, but we add the numerators. So we keep our 12, and then, Candace, we add 1 and 9, and that gives us... Candace, are you there?
Yes.
When we add 1 plus 9, we get?
10.
10. We have 10/12. Now we have to simplify that fraction. So we have to divide both 10 and 12 by its greatest common factor, which is 2. When we divide 10 by 2, we get 5. When we divide 12 by 2, we get 6. So our final answer after we simplify, Candace, is 5/6. Does that help you out?
Yes.
All right, very good job.
Candace, we really appreciate your call this afternoon. Did you want to try one of our challenges?
We gotta go.
Okay, we do have another caller, so if you'll give us a call back, we'll be able to help you. There is another caller. Caller, are you there?
Yes.
Hi. Can you tell me your name, please?
Kafalot.
Okay.
Kafalot.
Kafalot.
What school do you attend, Kafalot?
Excel Academy Public Charter School in Riverdale.
All right.
Well, please tell all your friends at Excel Academy that we said a big hello from Count on Us. And are you dividing fractions?
Yes. Dividing fractions with, dividing mixed numbers with fractions.
Okay.
Dividing mixed numbers. Okay.
What's your question, Kafalot?
Okay. My question is,
All right.
5 is the whole number.
5.
1/2 divided by 2.
5 and 1/2?
Yes.
Divided by 2?
By 2.
Okay. Now, the first thing we're going to do is turn both the mixed number and the whole number into a fraction. 5 and 1/2 as an improper fraction is going to be 11/2.
Yeah.
We're also going to write 2 as a fraction, which would be 2/1. So we have 11/2 divided by 2/1.
Yes.
Now, when we divide by a fraction, we have to multiply by what's called its reciprocal. Do you know the reciprocal of 2/1?
Yes, it's 1/2.
So we have 11/2 times 1/2.
Yeah.
When we multiply fractions, we multiply straight across. 11 times 1 is 11.
Yeah.
2 times 2 is 4. So we have 11/4. Now, if we were to convert that improper fraction back into a mixed number, 4 goes into 11. How many times, Kafalot?
4 goes into 11. Or it's 2 times.
Twice. 4 times 2 is?
4 times 2 is 8.
8. 11 minus 8 is?
3.
So our final answer as a mixed number is 2
3/4.
and 3/4. Very good job. Very good job. Does that help you out, Kafalot?
Yes.
Okay, I hate to cut you short, Kafalot, but we're up against time and we have one other call. You did a very good job.
Okay, and caller, are you there? Is this Essence?
Yes.
Essence, we really, really appreciate your patience. We were trying to help as many students as possible, and you have given us a call. You're ready to challenge yourself. Which challenge problem would you like to do?
B.
B as in boy?
Yes.
Okay, and we did have a solution for B already, so give us one. Did you see that solution?
Yes.
Okay, so you're going to give us one that's different?
Yes.
Oh, excellent. 7, 1, 5, and 4. Okay, go ahead. Let me have it.
5 plus 1.
5 plus 1 equals?
6. And then 7 times 4.
7 times 4.
Equals 28.
Okay.
6 minus 2. Never mind. I did it wrong.
That's 22. That's a good try, Essence.
That is a
24.
very, very good try. Maybe if we subtract right here. Okay, and I think we have time for our very, very last caller of the day. This is
Sam,
Samuel.
are you there?
All right, we can count on you, Sam.
Sam, are you there?
Yes.
Okay, come on, Sam. We got 60 seconds. Go. What's your question?
My question is 3x plus 4.2 equals 252.
Say that again, Sam.
3x plus 4.2 equals 252.
3x plus 4 and 2/10 equals 252?
Yes.
Okay. Will you want to subtract 4 and 2/10 from both sides?
Okay.
That gives you 247 and 8/10. You want to divide 247 and 8/10 by 3, Sam?
Calculator.
Okay.
Hold on the line. Okay, Sam, I need you to hold on.
Okay, and
Stay on the line, Sam.
And we will work out your problem for you off of the show. Mr. Belton!
Time flies when you're
Where
having
did the
fun.
time go when we were having so
All
much
right.
fun helping with math? And our winner is...
Candace, congratulations.
Candace from Stephen